let's put everything together now with some examples. So I'd like you to write down these 4 examples and notice that we have each example written in a different type of notation, or in one case a graph. So go ahead and write those down and then come back and we'll fill in the rest of the notations. Okay, welcome back. So the first thing that I want to do is let's go ahead and remind ourselves of what those funny little faces were so that we can use those as we go through this if we need to as a visual. Here we go. And so I always like to start with my graph. So I'm going to fill in graphs, the number lines for the ones that don't have them. So for this first one, I can see that I have critical points at -2 and at 3, and my graph has closed dots. Why? Because we have a less than or equal to sign, so X is in between here. And then on number 2, our critical points are -5 and -1. Notice that we have a parentheses on the left, open dot at -5, bracket on the right, closed dot at -1, X is somewhere in between. Number 3, we already have a graph, but I'm going to go ahead and just remind myself that this is going to infinity. And then finally, the 4th one is written in set builder notation, and I need X less than or equal to 5. So I know that 5 is my critical point, but then I need to decide which way my graph is going. And it is a closed dot based on having the less than or equal to, goes with this graph, closed dot. And less than means we go to the left to get smaller numbers. So I'm going this direction towards -infinity. I'd like for you to pause the video and see if you can fill in the other 2 blanks for each example. Once you've given it a try, come back and see if you were right. Okay, let's go ahead and finish out example 1. So we have less than or equal to signs. We know that we're going to be using our brackets for each. And remember that you have to write the smallest number first, -2, comma, +3, brackets, both ends. Our set notation or set builder notation, very, very easy to write because we already have our inequality notation. It's just inequality notation in these fancy braces, or -2, less than or equal to X, less than or equal to 3. All right, example number 2, we need to write the inequality notation from the interval notation. So let's look at that. We have a -5 and a -1. So those are our 2 points, and X is somewhere in between. So I'm going to stick X in the middle, put my smallest number here, my biggest number here. I have a parentheses on the left. So my symbol on the left needs to just be a less than. I have a bracket on the right, so that's going to be a less than or equal to. Once we've done that, again, our set notation becomes easy. Just copy our inequality notation. All right, finally, this next one, we start with a number line, so we need to fill in all 3 blanks. So let's start with our inequality notation. We see that X is starting at 1 and it's going to the right, so it's getting bigger. So X is greater than 1, right? It can be 1.11111. It cannot be 1 because we don't have the closed dot. Interval notation is going to start at 1, our smallest number, and head to infinity. And again, open dot and infinity goes with our parentheses. Finally, our set notation, X, our line for such that, so all real numbers X such that X is greater than 1. Don't forget that closing brace. Finally, we have a closed dot headed to the left, so x is going to be less than or equal to 5. Our smallest number, or what we're substituting for a number, is negative infinity, and our biggest number is 5. Infinities always get a parentheses. This was a less than or equal to, so it gets a bracket, and we are done with that. I want to go ahead and talk about the examples a little bit. Example 1 and 2 are considered to be bounded. That means that they have two endpoints, and x is bounded between the two endpoints. It's stuck in between them. Examples 3 and 4 are unbounded because they only have one endpoint and then go to infinity. So bounded versus unbounded depends on whether you have two endpoints or one endpoint and an arrow.